Hey guys, today I want to show you a test you can do on your e-bike battery to determine if the battery is in balance or if the battery is out of balance. If the battery is out of balance, basically no matter what you do, you cannot get a full charge on all the cells in the battery. And the only way you can get a full charge is to balance out the battery. Now, this condition comes about because what happens over time, the voltage in the battery cells changes. And what will happen is you'll have some cells that have higher voltages than other cells. Normally, the battery management system, or the BMS that's in the battery, will balance out those differences. But over time, those differences can become so great that the battery management system cannot balance them. So what happens, some cells will have higher voltages, some will have lower voltages. When you plug in the charger, it will only charge the battery up to full capacity for those cells which have the higher voltages. That means the cells with the lower voltages will not be fully charged. So even though it will appear that the battery is fully charged, in fact, because of the unbalanced condition of the battery, it will not be fully charged. Now, the practical outcome of all of this is that when the batteries become unbalanced, even though it will appear that the battery is fully charged, it's not fully charged, and the range that you will be able to get on your e-bike will go down. Now, there are two things you need to do if you suspect you have this problem. The first is you need to measure the battery cells to determine if they're in balance or out of balance. And the second thing you need to do, if the cells are out of balance, you need to go through a process to balance the battery. Today, I'm just going to go through the process to check the cells to see if they're in balance or out of balance. So let's get into it. Now, here is the battery that I'm going to disassemble and check today. This is an 840 watt-hour battery. It goes in a Dingfu E10. To check the unbalance, you need to be able to get to the individual cells in the battery. And so for the battery I just showed, I've removed the outside cover, and all I'm showing here, these are the cells. These happen to be Samsung 18650 E35 or 35E cells, and this is the battery management system. These little wires are the balance wires, and this is what we want to test, is the voltages in these cells in the battery. Now, to do this test, I'm going to use a multimeter. This is a fairly low budget multimeter. I'm going to be using the voltage function on this multimeter here, just to show you how I have it set up. There, I have it set up to test voltage, and I'll turn it on in a minute here. Now, the first thing you need to do is to go in, and this is the BMS, and you need to determine how many groups of cells you have in series. And the way I do that, or probably the best way to do that, is when you look right here on the BMS, and I'm sorry I can't quite get it focused in, but you'll see here that it says B13. So it goes from B0 to B13. So what you need to do is go in, and on these balance wires that are coming out of the BMS and are going around and attaching at different points on the battery, you need to go in and number them. So what I have, this one's number 13, and then you trace that all the way around the battery. So, but the first thing you need to do is go in and identify all the wires, number them 1 through 13. Now, the one that is, there is a wire that is labeled 0. That would be the first wire in that series. It's normally a black wire, and it's normally going down and attaching right here at with another large black wire. You'll just ignore this wire for purposes of this test. Do not you're not going to do anything with the zero wire there. Now, what you do is once you get these wires identified, so like here is the 13, when you trace it, the 13 attaches right here, and I put a 13 on the side of the battery. And what this is doing is there are 1 through 13 batteries connected in series. And what this battery pack has 65 cells, and the way those cells are arranged in this battery, the cells are grouped into groups of 5, and they're 13 groups of 5. So it's a 13S 5P, 13 in series, or 13 series and 5 in parallel. So you want to go in and mark where all those balance wires are going into, and that you'll see a place right where it's soldered. That's 9. You do the same thing on the other side of the battery. So here I'm showing where I have them marked. That's the 0. We're not going to do anything with that, but there's the 1, there's the 2, there's the 7, there's the 6, there's the 8, there's the 11. And that's the first thing, or one of the things you do here before you actually start the measurement. You need to have them identified as to the numbers based on the balance wires. Once you identify the number of packs you have, so for example, in this one, I know I have 13 that I'm going to have to measure. You need to create a little chart like this. Voltage readings, I put at the top. I start with B0, and I'm going all the way down to B13. Now, I'm not going to do anything with B0, but I don't want to forget about it, so I'm just going to put it on the sheet and put a big X just to highlight that I'm not going to be measuring that voltage. Now I'm going to take my multimeter and I'm going to test the voltages. So the first thing I do, I'm going to start at 1. You can start on any one of these, just not the 0. But on the 1, I'm going to take an alligator clip and I'm going to clip it right where the balance line is soldered. And I'm going to take the red end of my voltage meter, attach it to the other end of the alligator clip, turn on my multimeter. Here we go. And now I've got to try to figure out, because the way these are in here, I can't see exactly where it's attached, but by trial and error, I can figure it out. So there's a little piece of cover here. I'm going to go under that, and what I want to do is touch on the other side right here, and on that, for number 1, I have a 3.79 reading. So what I'm going to do, I'm going to go over on my sheet here and put on 3.79 volts for cell pack number 1 of 13. Then I'm going to move this over and go and do number 2. Cell pack number 2. Once again, I take my multimeter, I go in, go to the other side, and on this particular one, I'm showing a 3.89 reading. So what I'll do is I'll go in and I'll record that reading on my sheet. Okay, here's what it looks like on the sheet after I've done one complete side, and now I'm going to flip the battery over and do the other side. And here I go testing on the other side. I have it attached, I have it attached right here to the 13 pin. And once again, I'm going to go on the outside and measure, and 13 is 3.93. Now I'm just going to continue all the way down this side and get all of these and then put them on the sheet. Now at this point, I've finished all the readings and have them all on this sheet. And as you can see, the highest reading here is 4.10, and the lowest reading here is 3.76. So as you can see, this battery clearly is not in balance. One further point to note, that had this battery been in balance, what would have happened was all the readings would have been, probably within plus or minus 0.02 or 0.03 of a number. So, if the highest number were 4.1 and the lowest number was 4.07, and all the numbers were within that range, then the battery would have been in balance. But as you can see, this battery clearly is not in balance. Well, there you go, guys. That's how you check your e-bike battery to see if it's in balance or out of balance. I hope I've given you something to think about, and I'll see you guys at the top.